Bismillahirrahmanirrahim. Assalamu alaikum. We are doing chapter 11 and up till now we have done triangles and quadrilaterals. So it's time now to start polygons. So what is a polygon? Simply we can define it. A polygon is a plane figure with at least 3 sides and angles. When we say at least 3 sides, what comes to our mind? Of course, a triangle, right? And triangle has its angles, and there are different type of triangles. If we keep on adding a side, if we keep on adding a side, we can have, after adding one side, we will have a square or a rectangle or a parallelogram, and then if we add another side, it becomes a pentagon, another side hexagon, and it keeps on going. Okay, so let's start a polygon. And before that, one more thing. If all the sides and angles of any polygon are equal, then we are going to say that it's a regular polygon. Okay, otherwise it's not a regular polygon. For the regular polygon, either it's a triangle, square, or pentagon, or a hexagon. The sides have to be equal, and the angles have to be equal. Then it's a regular polygon. So when we are doing polygon, so first thing, if we have a triangle, now although we know what is the sum of interior angles of a triangle, but since from a triangle we are going to move towards a polygon with having more sides, so it's time now to have a formula to calculate the interior angles of a polygon. So what the formula we are going to use for the sum of interior angles? The formula is n minus 2 into 180. Okay? Now in case of a triangle, this n represents number of sides. So if we are talking about a triangle, how many sides do we have here? 3. So 3 minus 2 into 180, so it is 180. Because 3 minus 2 is 1, so it is 180. And we already know that the sum of interior angles of a triangle is 180. But with this formula, we can calculate it like this. Okay, suppose we have a square. So in case of a square, sum of interior angles equals, now the number of sides are 4, so 4 minus 2 into 180, which is 360. And from a square, if I move towards pentagon. Okay, now in case of pentagon, (5 minus 2 into 180, which is 540. So we can keep on moving by adding one side, and we can have sum of interior angles with using this formula. Okay, now we know that how to calculate the sum of interior angles. Now from an interior angle, let's move towards exterior angles. What will be the sum of the exterior angles? Because with this, we do have interior angles, but with every figure there are exterior angles as well. So first let me tell you what do I mean by the exterior angles. Where are the exterior angles? We'll start with a triangle and then I'll move towards other shape. First let me let you know that where are the exterior angles. Okay, now I have extended the sides of a triangle. I have extended this side, I have extended this side, I have extended this side. Okay, now let's say that these are the three interior angles and I'm going to name them A, B and C. Okay, now since I have extended this side, I have an angle here as well. This angle is interior, but if I am extending this line, I am having an angle over here as well. And this is an exterior angle. I am having an angle over here as well. This is also an exterior angle. An angle over here. This is also an exterior angle. So, if I name these angles as X, Y, and Z. Okay. Why I am naming these angles? Because we need to know what is the sum of the exterior angles also. Because we know that sum of the interior angles with this formula. But if it would be a beneficial thing if we know what is the sum of exterior angle of any polygon also. So, okay. Now, if we look at this thing, this is a straight line also. And on a straight line, I am having a this angle and a this angle. And since these angles are sharing a common vertex, and remember, if they are having a common vertex, we call them their adjacent angles. And the adjacent angles on a straight line are equal to 180 degree. So these two angles are adjacent, these two angles are adjacent, and these two angles are adjacent. It means that sum of the adjacent angle is equal to 180 degree, right? Okay, so X plus A, one pair of adjacent angles, okay, plus B plus Y, another pair of adjacent angle, then plus C plus Z, another pair of adjacent angles. And how many pairs I have used? I have used 3 pairs, right? Why 3 pairs? Because we have 3 sides. There are 3 sides of a polygon, okay? And each side, on each straight line, the sum of adjacent angles is 180, right? So I have used 3 straight lines into 180, right? Now, with this, if I add angle, it will be more meaningful. Let me do that. Angle Z, angle C, angle. Because I'm adding angles, so having angle sign is good thing. Okay. So now what am I going to do? I'm going to separate the interior angles and exterior angles. So angle A plus angle B plus angle C, these are all interior angles. Now plus angle X plus angle Y plus angle Z is equal to 540. So interior angles, exterior angles and a sum. Okay now, but we know that this, because since it's a triangle and the sum of the interior angles is 180, right? So angle X plus angle Y plus angle Z is equal to 540 minus 180, and which is equal to 360 degree. So in case of a triangle, the sum of exterior angles is equal to 360 degree, right? To generalize this thing, let's take another figure. I'm going to take Pentagon, and let's see what is the sum of exterior angles to the Pentagon, and then we'll generalize this thing, okay? Okay, I have a pentagon now, right? 5 sides. And we know that with this formula we can calculate the sum of interior angles. Now I need to know what is the sum of exterior angles for the pentagon. So for that, what I'm going to do, I'm going to extend all the sides. So I'm extending this side, I'm extending this side, I'm extending this side, this side, this side. So, and these are the interior angles, and I can name the A, B, C, D and E, right? And all these straight lines which I have extended are making an exterior angle. Here is an exterior angle, here is an exterior angle, here is exterior angle, here is exterior angle, and here is an exterior angle. Okay? So I'm going to name them also. So we can say V, W, X, Y, and Z. Okay? Now I have 5 interior angles and 5 exterior angles, right? How many sides do I have? 5 sides. Now, for the sum of exterior angles, of a pentagon, what I am going to do? Pairing the sums, because they are adjacent angles on a straight line, and which is equal to 180, right? Angle A plus angle B plus angle B plus angle W plus angle C plus angle Y plus angle E plus angle Z is equal to 5 sides into 180. Why 180? As I have told you in the case of triangle, that we have 5 sides, and on a straight lines the adjacent angle equals 180 degree. So these are all pair of adjacent angles, and there we have 5 sides, 5 into 180, and sum of adjacent angle is also equal to 180. So I am going to separate now interior and exterior angles. So angle A plus angle B plus angle C plus angle D plus angle E, now plus angle B plus angle W plus angle X plus angle Y plus angle Z is equal to 900. Okay. Now the sum of interior angles to a pentagon is equal to 540. Okay. So the exterior angles (900 minus 540), which is equal to 360. Okay. Now the sum of exterior angles to a triangle was 360. Sum of exterior angles to a pentagon is equal to 360, and you can try for any quadrilateral. It's going to be 360. So no matter what polygon do you have, so it's now a rule. The rule is sum of exterior angles for any polygon equals 360. So now we have two ways we can have interior angles with this formula, and the sum of the exterior angles for any polygon is going to be 360. So it will be very helpful for calculating angles for any polygon. So let's do some examples also now. So okay, now I have a pentagon here, and assuming that it's a regular pentagon, and if it's a regular pentagon, all sides are equal or angles are equal. Okay, we need to know what is the size of each angle. So what are we going to do here? Since we know with this formula that sum of interior angles of a pentagon is equal to 540. Okay. Now how many angles here we have? 5. So all are equal. So we have A plus A plus A plus A plus A is equal to 540. So 5A is equal to 540, and A is equal to 540 divided by 5, which is 108. So each of this angle is of 108 degree, right? If we know the sum of interior angles, to know the angle of any regular polygon is not difficult. You can apply this formula and you can calculate for any polygon, right? Now suppose we have some irregular polygon. Now what is going to happen? I'm going to change a couple of angles here. I'm going to say if it is 120 and this is 105. Now what happens? I need to know the remaining three angles. Okay. Now what am I going to do? So it is 3A plus 225 is equal to sum of interior, because there are 5 sides, it's going to be 540. It's going to remain the same, but it's not a regular polygon then. So 3A is equal to 540 minus 225, which is 315, and A is equal to 105 degree. So it turned out to be the 4 sides of this 4 angles of this irregular polygon are of 105 degree, and one is of 120 degree, right? And it's an irregular polygon. Now let's take example of some exterior thing. Okay, let's do that. Okay, the example we have here is a find of sum of find sides of a regular polygon if the exterior angle is 60 or 40. Now we know that the sum of exterior angles is equal to 360 degree, right? Now if any of the it's a regular polygon, and any of the exterior angle is 360 degree. So what are we going to do? So number of sides equals 360, because it's a total, divided by 60, and it's a 6-sided polygon, right? So it's a hexagon. And if the angle is of 40 degree, what do we have here? 9. It's a 9-sided polygon, right? So if we know any of the exterior angles, it's a regular. Why we are saying regular? Because of regular, all the exterior angles will be the same. The sum is, we know that the sum for any polygon for the exterior is going to be 360, but each and every exterior angle, because it's a regular polygon, it will be the same. So this was the case for the regular polygon. We knew that if it is 60, then there are 6 sides. If it is 40, then there are 9 sides. Now let's take another example. Okay, we have to find the number of sides for the regular polygon. Now in this case we know the size of the interior angles, which is 120 or 90. It's a regular polygon. We have to find number of sides. Okay. Now we know that each and every side of the polygon is having an interior angle and an exterior angle. So supposing this is some side of a polygon, okay, and I am extending this side. With this, here we have interior angle, and here we have some exterior angle, okay, and both are adjacent. Supposing now, if this is of 120 degree interior angle, so this will be of 60 degree. Why? Because sum of the adjacent angles is 180 degree, right? So what am I going to do? For this case, the interior angle equals 120, therefore exterior angle equals 60. So if the exterior angle is of 60 degree, what am I going to do? 360 divided by 60. So it's a 6-sided, it's a case of a hexagon, right? Now, if interior angle is of a 90 degree, then what are we going to do? 360, because why 360? Because exterior angle, sum of exterior angles is 360, and 180 minus 90 is 90. So dividing by 90, we have 4. So because it's a regular polygon, so it's a square. It's a hexagon, it's a square, right? So it was a hexagon and it's a square. Okay, now I hope that you got some idea how to calculate the interior angles and exterior angles for any polygon. And if we have the concept of the exterior and interior angles, we can calculate for any polygon starting from triangle towards n-sided polygon. Okay, thank you very much for now, and keep sending me your feedback. Thank you.